Okay, 1.2, finding graphic limits graphically and numerically. So yesterday when we read through 1.1, we discussed the fact that calculus was the talking about continuous change, not static change, correct? Not constant change. And we talked about the limits problem and how it works. So today we're going to look at.
I've seen it first was dead, as was mine.
Okay, so today we're going to look at the basic form of finding a limit. Now, the two things that we look at today are going to be graphically and numerically, meaning in a table. They are your last resort after you learn how to do it algebraically, numerically. Okay, so when we are finding limits as we go through these processes, you always try to reduce, to do direct substitution. Graphically and numerically are your last resort when it comes to once you've learned all the methods. Does that make sense? So this should not be where you jump to. If it is where you jump to on the test and it's not appropriate, then you will lose points, not because you didn't get the limit right, but you didn't use an appropriate method. Okay, so it's frozen. So you have up here an equation. You have f of x. And I don't know if writing all of these examples is going to be what you're going to want to do. If you want to go write them all down, they're in the textbook. They are straight from there. So we have a function f of x equals x cubed minus 1 over x minus 1. So if we were to graph that, we would factor the numerator because that's a difference of cubes. And the x minus 1 would reduce out in both, would it not? Because this would be x minus 1 and then x squared plus x plus 1. And the x minus 1, because that would be that difference of cubes. So that x minus 1 would reduce, and this is a quadratic equation. Yes?
Yeah.
Correct. What?
Okay, where do you have the arrow pointing to? That's just an example, not a formula, right?
No, that's just a random equation.
That is just
Okay.
that graph.
So we have this graph right here. It's a parabola. Why is there a hole right here?
Because
At
the
1, why is there?
denominator, it states that x cannot equal 1.
Right. The denominator x can't equal 1. It's an excluded value. It would be a hole in the graph. Last year I talked about that. If you were to graph it, it'd be a hole there, but I didn't push you to put it in. We just need to know that it doesn't exist. Okay? So this is the graph. This is what we would get if we graphed it. So what I want to know is the limit, L-I-N-M, stands for the limit, as x approaches 1, that arrow means approaches, of f of x. This equation is f of x.
Mm-hmm.
Okay? So you don't know any methods right now. I know a method right now that I could tell you it's 3 without looking at my table or my graph. But you don't know that method yet. So we're going to take it back to basics like when you first learned a graph. You would make an XY chart and you would just plot the points and connect them. So that's where we're going. So what we do is what it has this, it means approaching 1, not at 1, because what do we know at 1 this graph is?
At 1.
At 1, it's a hole. What's that mean it is? Undefined?
Yeah.
Yes. So at 1, this graph is undefined. It doesn't exist. It could exist, but it doesn't. So I want to know what it's approaching. So when I talk approaching, I'm talking from the left and the right. So this is from the left, and this is from the right. What value, because f of x means y, correct? So as the x value approaches 1 from the left and the right, what is the y value approaching? Look at the picture.
I'd say about 3.
It would be 3. Yes?
Yeah.
Now, if I look at the table, look at my amounts on this table. 0.75, 0.9, 0.99, 0.999, 1, and then 1.001, 1.01, 1.1, 1.25. They're small, yes?
Yeah.
Okay, so I'm going to show you today how to make your calculator make these kinds of tables. And then we have these values. What are the y's or the f of x is approaching as I'm approaching 1 from the left, 3. And from the right, what is it approaching? 3. So my limit is 3. But at 1, what is my value? Undefined or does not exist, correct?
Yes.
So there's a difference. We are not asking what it is at 1. It's what is it approaching. Does everyone see the difference between those two statements? Because that is the key to this whole assignment. This whole chapter is understanding the difference of what it is at 1 and what is approaching. Now, it will eventually be some problems. It will be what is it at 1 because it's defined and it's continuous and it's nice and pretty, but not always. Okay, are you good to go on?
Yeah.
Okay, so it's like, let's see more, Mrs. Mick, because I'm not sure. Okay, so right at the top, if f of x becomes arbitrarily close, what's arbitrarily? Vary. Okay. And we're not saying it was exactly 3 because it was never exactly 3, was it?
No.
It was just arbitrarily close to 3. A single number L as x approaches C from either side, the limit of f of x as x approaches C is L. This limit is written as such. Now, this is not the way you're going to write it, but is the way my computer program writes it for your test. Is like this. The way you are going to write it, and I'm going to say it as I write it, you're going to write it the limit as x or n or whatever, and I always forget my other, n approaches C of whatever equals L. Do you see that? That n approaches C is little underneath it. On the last slide, and even down here, you see it down here?
Yeah.
That's how you're going to write it on your paper. My computer program says it's going to write it like that, and I put it in, and it doesn't. And sometimes it does. So I don't know how to make it do it all the time. I haven't figured that out. So I'm hoping in Word it does a little bit better. But whether it is underneath it or right next to it as a sub, see it's right next to it as a sub, it means the same thing. Capiche? Okay, now I would like you right now to write this equation right here. The limit as x approaches 2 of x squared minus 3x plus 2 over x minus 2. And this table, not putting the question marks on the f of x's, leaving those open. Now make your table big enough that you can write some decimal places. Okay? And then I'm going to show you how to use your calculator to do this. You are going to be constructing tables today. I think you're going to be graphing. You know how to sketch the graph that you get. On the table, you need to write the table that you get on your paper. That's showing your work.
Okay.
Guys, got your table done yet?
I'm drawing lines in it right now.
Okay. You got numbers though. So I can get my calculator. Since I have my program, okay. So on your calculator, we've established before, and we've done this, we've graphed, we've made tables. To do this, we need to hit y equals And we need to put our equation in y1, in some y. It doesn't matter. But remember to put parentheses around your numerator. So put your equation in there and denominator, sorry. So x squared minus 3x plus 2. Natalie, let us know when you have it in your
Sorry.
Nope.
I have it.
Got it?
Yeah.
Okay. So we're going to make a table. We first need to go to table set to make it do what we want. So where's table set?
Second window.
Second window. Okay. So we have a table. Right now this table is starting at 0. The change, delta means change, right?
Yeah.
The change in the x's would be 1, and it would spit out a table for you. But we don't want all that, and we definitely don't want our increments to go by 1, do we? Because the values were 1.75, 1.9, 1.99. We don't want that. So we want to go down, so arrow down to your input. And this is how I grade your tests, to be honest with you. I go and change it to ask and hit enter. So now we can put whatever values of x we want in there, and it will spit out the y's.
Yeah.
So now go to table. Where's table at?
Somewhere around
Anything with a graph or a table is up top. So second graph. And you have a table. And now you're going to punch in your numbers.
My table has stuff in it.
there. Then you didn't clear out.
Then just clear out your table. Just type over it. It's fine.
Oh, okay.
Why is there an error at 2?
Because it's not in the domain.
It's not in the domain. It's an excluded value. It's undefined at that point.
So what do we put in that box then? Just und.
Oops, go 2. Or did I mess up? Yes, you just write undefined. Oh, I put 2 decimal places. Oh, how about I fix this one? Look at the one before it. That was really good. Well, you know.
It should be 2.2.
I know. I don't know what. You guys ever see that these newer calculators, like when you hit 2, like it's 2, 2, it doesn't always register the second 2? I think it's because I don't always.
Where was this?
Yeah, you got an old one.
Undefined.
An old one.
I have not noticed that on my calculators.
Oh, I've noticed on my newer one that it doesn't always, and I think it's because I probably don't like let up off the key all the way.
Yeah.
Okay, so you have your table. It's made the table. The worst part you got to do is write all that stuff down, right?
Yeah.
So now we're going to look at from the left. Left comes from smaller numbers, right? From the left, what is it approaching?
1.
1. Ooh, that's interesting. And from the right, what is it approaching?
1.
1. So what is the limit?
1.
1.
It's just L equals 1.
Well, it's not L. We just said it. We just write it equals 1.
Oh, okay.
Like you wrote the problem.
Yeah. Oh, okay.
So we just say equals 1.
So it's just like the number closest to undefined.
From both directions. Now, we do have, you guys wrote undefined here, and I said doesn't exist, and I shouldn't have done that. I should have said undefined, because we do have limits that do not exist. And we're going to talk about that. Are we all good to go to the next?
Let's
Yeah.
go.
Okay. So Not yet, though, I guess. Okay, this is yours. The limit as x approaches 0, you don't have to do anything because it's all in front of you. Okay, the limit as x approaches 0 of x over the square root of x plus 1 minus 1. You have a graph and you have a table. What is y approaching as x approaches 0?
2.
So this direction it's approaching what? 2. This direction it is approaching 2. This direction it is approaching 2. And this direction it's approaching 2. So the answer is 2. We got this? Okay. What about this one? Now, this one isn't written, so how do we write it? It says the limit of f of x as x approaches to where x is defined as. So we have this, right? We basically would write limit as x approaches 2 in front of that. Okay? We can do it of any equation. That's why I threw a piecewise one on here. So, from the left, we're approaching what?
2.
Nope.
1.
1. We're talking y values.
Yeah.
From the right, we're approaching 1. So the answer is 1. But what if they're not the same? If they're not the same, we have common types of behaviors associated with non-existence of limits. Or, from our Mean Girls quote, the limit does not exist. Okay? D, N, E. If the limit, you've never seen Mean Girls?
No.
I think we have to watch it. I don't know what you're talking about. The one.
He turned, the limit does not,
It's a movie where she's on the math leads and she's trying to get the last answer right. And so she's thinking back to when she was.
okay. So we have reasons why they would not exist. If you tell me the limit does not exist, you have to tell me why.
No.
Stood? And there's 3 reasons why. 1, f of x approaches different numbers from the left and from the right. Okay? From the left and from the right are 2 different values. We will discuss next week left and right hand limits. But when you don't specify a left and right, it is both. Does that make sense? So it approaches 2 different values. It doesn't exist if f of x increases or decreases without bound as you approach c. That's specific, not in general. Like the graph, it can approach, but if your c is there. Okay? Now, I will have examples of all 3. Okay. F of x, the third one is f of x oscillates between 2 different values as it approaches c. Now, I'm going to tell you that 1 and 3 sound really similar, correct? Because 2 different values. You will tend to have 1 and 2 be your reasons why more than you have 3. 3 happens a lot when we have trigonometric equations thrown at us that look like sine and cosine, because what does sine and cosine do?
They oscillate.
They oscillate.
What's your on word?
Oscillate?
Mr. Emerson made fun of me for like 3 years for using the word oscillate one time in track.
Did you use it incorrectly?
No.
Oh. Well, the S is cut off. There is an S on approaches. I promise. It's on my screen.
Where?
It's on my screen.
Oh, over there. I was looking at the other 3 approaches. I had not yet approached that one.
I did notice that it was cutting off part of your.
Was it doing the other things?
It was just, well, on the other side, yeah, it was just cutting parts of it off. But I'm sure that wasn't important anyway.
See, it's there. I want it as big as I can get it and wide as it. So I guess you're just going to have to deal with it. Okay, we done yet?
No. You were covering it. No, I'm done.
Okay. Are you good? Okay. Okay, so here's an example of what it would look like if it was approaching two different values, and this is not going to work because it is cut off.
Oh,
Ooh.
There.
I like that.
Okay, kind of stretched, a little bit disproportionate, but oh well. Okay, so the limit as x approaches 0 of the absolute value of x over x. This is what it looks like right here. Okay?
Okay.
So we're approaching 0. Well, from the left, it approaches what?
Approaches 0.
Y approaches, the x is approaching 0, y is approaching
-1.
-1. From the right, x is approaching 0, y is approaching 1. Are those two different values?
Yes.
Yes. So you would write DNE, y approaches two different values.
I'm so sorry.
Okay? Does that make sense now that you see the visual?
Yeah. It was the other one I was
Yeah.
confused about.
You'll say it all. And I'm going to tell you the next one is, are you guys good for me to go? Okay. The next one is where it gets a little tricky. So this does not exist because as x approaches 0, from the left it's approaching positive infinity and positive infinity. Can I get to positive infinity? No. So it does not exist. Increases without bound. Okay, so, but what if I ask you this and I didn't say 0, I said -1? Same graph, but -1. So from the left, it's approaching, we're going to say 1, okay? And from the right, it's approaching what? 1. So my answer would be 1. It's where C is at, okay? That's when people say, oh, it's increasing without bounds, so nope, can't do it. No, it's at the C, okay? Now, but what if this one went this direction and this one went this direction? It does not exist at 0, yes.
But they're
But
approaching
for-
different numbers.
Yeah,
It's approaching different values, but it's also increasing and decreasing without bound. But I would prefer it's approaching two different values. But
Or both.
yeah, or both.
Bofa.
Both would even be better. Okay, am I good? Now here's your oscillation one. So if I zoomed in on this graph, right here, it would be just bouncing back and forth really, really quick. And it's not making up its mind. Okay? So at 0, it may have a value at 0, but not very long, correct? So again, can you see why this would happen more with like sine or cosine as we messed with it? Yeah. Oscillation between two different values does not typically happen with non-cyclical functions.
So does the oscillation just mean all the bouncing?
Yeah.
Okay.
It's just going back and forth between two values as it's coming so quickly. Like if it was nice smooth curves, that's not really an oscillate. You know what I mean? It's when the period gets so small, it's just bouncing. Like it can't decide. Make sense?
Yeah.
Okay, that's your notes for today.